Hello everybody, let's do a quick revision of chemical kinetics which we have already done in class. First of all, chemical word relates to study of substances, their properties and reactions, and kinetic word refers to study of motion, rates and speed of process. So it literally means the study of rates and speeds of chemical reactions. So now what is the rate of a reaction? See, rate word refers to speed of reaction over time. Okay. So speed of reaction means change in concentration of reactants or products with respect to time. See, let's think of it like baking a cake. Now, knowing the baking time ensures the cake is cooked perfectly or not undercooked or overcooked. So, understanding reaction time helps manufacturers control the process, ensure quality, and of course, optimize production. Here it is the formula delta of A divided by delta of T, since we have taken general equation of A and B. Here A is reactant, B is product. So mathematical expression became delta of A divided by delta of T. Here negative sign indicates that there is decrease in concentration of reactant while products are goes on increasing. So now question is, how do we calculate the rate of a reaction? For this we definitely need the information of time in seconds and reactant. So now let's understand this by taking an example. When bromine is reacting with formic acid, that is HCOOH, and forming bromide ion plus 2H positive, that is hydrogen ion plus carbon dioxide gas. What is happening here? Formic acid is oxidized to CO2, losing electrons. Bromine is reduced to bromide ions, gaining electrons. So rate of reaction refers to how fast the reactants are converted into products. So average rate of reaction is change in concentration with respect to a specific time interval, and instantaneous rate of reaction is rate of reaction at any instant of time is the rate of change of concentration of any type of reactants or products at that particular instant of time. So here these are some rate calculations when we took the example of bromine. Here it is, average rate will be negative of Br2 minus Br2, that is final and initial, divided by final time minus initial time. So here we are talking about reaction rates and stoichiometry. Stoichiometry refers to quantitative relationship between the reactants and products in a chemical reaction. Alright. See, it helps you determine basically two major things. First is how much product will be formed from a given amount of reactants. And second is how much reactants are needed to produce a certain amount of product. So here is the example. Methane is reacting with oxygen, 2O2 forming CO2 plus 2H2O. So rate will be of methane, CH4 will be negative of delta CH4 and negative half of oxygen. Let's take an example of this. First reaction, I negative plus OCl negative. See here in the reaction, chemical reaction, of each of stoichiometric coefficient is equals to 1. So negative sign. When it came to product, negative is plus, minus plus. Here again in this example, rate of NO2, rate of reaction became minus of 1 by 4 of change in NO2 divided by delta of T, change in time interval. First from the preceding rate expression we have negative of O2 divided by delta T. So we combined them. Now rate constant. If concentration of each of the reactants involved in any kind of reaction is taken to be unity, that is if concentration of A is equals to concentration of B is equals to 1, then rate of reaction will be K into 1 will be K. That is called rate constant. Now rate law. So it expresses the relationship between rate of a reaction to rate constant. That is A, small a into capital A plus B of B give raised to CC plus DD. That is rate will be, that is equals to small k rate of constant, concentration of A raised to power X and concentration of B raised to power Y. So reaction order, another thing is reaction order. Order of a reaction is defined as sum of exponents to which concentration terms are raised in the rate equation, or we can say in the rate law of reaction. So here it is. So now example is, what is the rate expression for AA plus BB give rise to CC plus DD, where X is 1 and Y is 2. So it is overall, you can see reaction order will be 2 plus 1 is equals to 3. Now this is a general rate data for the reactions between fluorine. So if I am starting from F2, that is fluorine, then reaching up to ClO2. So this is the general data, general reaction order became. The reason here that is explained in the written form, that is if initially F2 is 1.0 m and ClO2 is 1.0 m. So what will happen to the reaction rate if F2 is doubled? If fluorine is twice of its order, then how it gonna proceed? So it is completely explained in this form. You can see that is displayed on the screen, that rate of 1 will be different from rate of 2. That's quite obvious because the quantities are different. Now molecularity of a reaction. It is the number of reacting particles. Reacting particles can be atoms or molecules or any other species which collides simultaneously to bring about the chemical change. So it is a theoretical concept. This we need to clarify here. Its value will always be a whole number. So now the difference between molecularity and order of a reaction, you can see that is displayed on screen. So next we're gonna do zero order reaction. If rate of reaction doesn't depend upon the concentration of any of reactant, that is called zero order reaction. Okay, if we talk about like decomposition of ammonia on the surface of metal like tungsten, so that will be, whose order of reaction will be 0. So if order of reaction becomes 0, that means it is a zero order reaction. Next is first order reaction. If rate of reaction depends only upon one concentration term, then reaction is called first order reaction, right? So another, the most important topic came, pseudo first order reaction. Pseudo means false. So it means those reactions which are not truly of first order, but under certain condition reactions becomes some different reaction. So that will be a pseudo order. So another is second order reaction. In this, if sum of powers of reacting species in a rate law is 2, it is called second order reaction. Also, I am providing here mathematical expressions on screen, so you can check it all. You can check all of these, and also we already discussed in class. So the main point we are going to discuss now, the factors which will affect the rate of a reaction, that is nature of reactant, concentration, temperature, and all of these above. How they gonna affect? First of all, effect of temperature. See, temperature is what? Which will provide energy to the reactants, which will provide heat to the reactants.